Advanced Algebra 2, Characteristics of Quadratic Functions, Concept 7 Notes. The first thing we're going to talk about is graphing a quadratic that is in vertex form. So remember, this is the form y equals a times x minus h squared plus k. When you graph it, you get a parabola, and then the parabola would be translated horizontally h units and vertically k units, and then stretched or shrunk by a factor of a. And remember, if a is negative, then we will have an x-axis reflection. So the characteristics in parent form is that the vertex is at the coordinates h, k. The graph will open up if your a value is greater than 0, and will open down if the a value is less than 0. Your axis of symmetry always goes through the vertex and has the equation x equals h. Your domain is all real numbers, and the range is greater than or equal to the k value if it opens up, and less than or equal to the k value if it opens down. And then the y value of the vertex will either be a minimum or a maximum, depending on how that quadratic is behaving. So here are the steps to graph a parabola by hand in vertex form. First of all, pick out the vertex, the h and the k values. Find the axis of symmetry, which is easy. It is just the vertical line that goes through the h value, and it is the equation x equals h. Then you're going to make a t-chart, and from the vertex, you're going to plug in two values in the negative direction for x and two in the positive direction for x. That will give you 5 good points to graph for your parabola. You'll always remember that parabolas are symmetrical and use that property of symmetry. So let's look at this example. Y equals negative 2, x plus 3 squared plus 4. So let's pick out the h and the k values. H is negative 3 and k is 4. So our vertex is at the point negative 3, 4. Our axis of symmetry is the vertical line x equals negative 3. So now let's put our equation in a space above our table, and we're going to start with our vertex, and I place that in the middle of my table. And then I'm going to do two values in the negative direction for x and two values in the positive direction for x. So these will be symmetrical points around the vertex. So I start by plugging in these numbers and look at the y values. See how those values behave. They are symmetrical. Negative 4, 2, 4, and then 2, negative 4. So if you create a table of values with the vertex in the middle and then symmetrical values to the left and the right, you'll have a pattern like this. So now let's graph this. Label your xy axes and a scale, always, all right? And then place your points. Draw a smooth U-shaped curve as best you can, and then put a dashed line right down the middle. This represents the vertical axis of symmetry, and that's x equals negative 3. Now let's identify the domain and the range. So the domain for a quadratic is all real numbers. You can plug in any number for x and get a real number value y. Our range is limited though. So the highest y value is at positive 4. So it is a maximum. So the range are all the values of y that are less than or equal to 4. Let's talk about the transformations occurring. This parabola has x-axis reflection. It is a stretch by 2. It has been shifted 3 to the left and 4 up. And our graph reflects that. So everything is a go. Let's try another one. So y equals 2/3 x minus 3 squared plus 7. Thinking in vertex form, pick out your h and your k value. Remember, h is the opposite of what you see, so positive 3. So our vertex is 3, 7. Our axis of symmetry is the vertical line x equals 3. Now I'm going to place that equation in the space above my table and start by placing my vertex. I'm going to place two values in the negative direction and two values in the positive direction, and I'm going to plug in each of those numbers and see that I do get symmetrical values. If you get a decimal or a fraction, I usually like to put it in decimal form and just round to tenths place. So now let's graph those points. I notice that my y values are all positive, so I'm going to adjust my xy axis. You can do that. You do not have to place your xy axis right in the middle of your graph space. You are master of your graph. So now we're going to plot these points, draw a smooth U-shaped curve, and then dash that axis of symmetry right through where x is 3. Our domain, of course, is all real numbers, and our range are all the y values that are greater than or equal to 7 because it is opening up, and 7 is our minimum. So this is a shrink by 2/3, a shift right 3, and 7 up. And our graph reflects that. Now let's talk about graphing a quadratic in standard form. This is the form y equals ax squared plus bx plus c. Remember that a, b, and c are constants. The graph opens up if a is greater than 0 and down if a is less than 0. To find the axis of symmetry, we're going to use a little formula, the opposite of b divided by 2 times a. Domain will be all real numbers again, and our range, we're going to talk about it in terms of k. But in this case, a equals what the function value is once you plug in the x value of the vertex, where from standard form you find that by taking negative b divided by 2 times a. So let's fill out our table for our steps to graph in standard form. First, you're going to find the axis of symmetry by taking the opposite of b divided by 2 times a. Then to find the vertex, that is the x value of the vertex, and you simply want to plug in that x value into the function to get your y. That's what that notation means. In standard form, the y-intercept is the c value, so you always have the point 0c that you can plot if you'd like. And then we're going to do the same thing. We're going to start with the vertex and plug in 2 values in the negative and 2 values in the positive direction to get 5 points to graph. So let's graph 3x squared minus 6x plus 1. I like to start out by picking out my a, b, and c value. Notice the sign goes with it, so my 6 is negative. Now, to find the vertex, I start by finding the axis of symmetry. So the opposite of b, so it's positive 6 divided by 2 times 3, which is also positive 6, which equals 1. So that's the x value of the vertex. It's also the axis of symmetry. Let's plug in 1 into the equation and find out what our y value is of the vertex. So our y value is negative 2. Axis of symmetry, remember, is that line x equals 1. So now let's create our table. I just like to remind myself what equation I'm plugging values into. I start with my vertex at 1, negative 2, and do x values in the negative and positive direction. And I should get symmetrical y values, which I do. I notice that my y values go up to 10, so I'm going to adjust my axes a little bit and then plot those points. Now my graph is a little pointy. This should actually be a nice, smooth U-shaped curve. You can graph it on your graphing calculator or Desmos and take a look. And so always just go for smooth U-shape rather than a V if you can help it. Our domain, you've got it, is all real numbers. And our range is y is greater than or equal to negative 2. And this is a minimum. Let's look at 2b. So we've got negative 2 x squared minus 8x plus 1. So let's start by picking out the a, b, and c value, finding the x value of the vertex, which is also the axis of symmetry. So that will give us negative 2. Now plug in negative 2 to your equation, do the math, and you should get positive 9. So our axis of symmetry is the line x equals negative 2, and our vertex is negative 2, 9. So we'll start with that in our table. And then we'll step down 2 in the negative direction and 2 in the positive direction, 2 numbers. And we see we get those symmetrical y values. Notice that this graph is opening downward, so those y values make sense. I decide to put my axes right in the middle again, and then let's plot our points. Smooth U-shaped curve, and then dash that axis of symmetry. Domain is all real numbers, and the range, see how it's opening downward? It's less than or equal to all the y values that are 9 or less, and that makes that point a maximum. So let's talk about intervals of increasing and decreasing with a quadratic. So you're going to, with a quadratic, find the axis of symmetry and then identify the range of of x values on each side of the axis of symmetry. You're going to follow the shape of the graph, reading it left to right. So if your eyes fall, then the graph is said to be decreasing. And if it rises, it is said to be increasing. So if we look at the graph over on the left and read it left to right, notice that first your eyes fall. So it is said to be decreasing until we get to that axis of symmetry, that h value. And then we say that it's increasing on all the x values that are greater than that axis of symmetry, or h. And then our second graph first is increasing on that interval of x being less than whatever h is, and then decreasing on the interval where x is greater than whatever that h value is. So let's do one. I think it'll make more sense to you. So notice we have this equation in standard form. We want to find the axis of symmetry. So remember, we can pick out A, B, and C, and then use our formula, the opposite of B, divided by 2 times A. So that will give us positive 2. Let's plug in 2, and we'll find out what the entire vertex is. So we can get a picture of this parabola. So it has a vertex at 2, -3. I look back at the equation. Notice my A value is positive, so it's going to open up. So my vertex will be a minimum. My domain will be all real numbers, and my range will be all the y values that are greater than or equal to -3. Now let's do a very brief sketch of this parabola. So let's just throw down an xy axis. We're going to sketch where the vertex is at 2, -3, and then just create a parabola that opens up. Now we can read it left to right. So first our eyes fall. So on the left side of the axis of symmetry, our graph is decreasing, and on the right it's increasing. Now we need to give an interval, so an inequality of where it's increasing or decreasing. Since our axis of symmetry is at 2, then we say that this graph is decreasing where x is less than 2, because it's on the left side of that line, and increasing where x is greater than 2. So that's how you express the interval where a quadratic is increasing or decreasing. Let's try these two. So first let's put this in standard form, -x squared minus 4x. Then let's pick out A, B, and C. Now let's find the x value of the vertex, which is also the axis of symmetry, which is -2, and then plug in -2 into the equation. +4. So our vertex is at the point -2, 4. Notice our A value is negative, so this graph is opening downward. It has a domain of all real numbers and a range of our y's that are less than or equal to 4. So a very brief sketch at the vertex -2, 4 with the parabola that opens down will reveal that on the left side of that axis of symmetry we are increasing. So we're increasing over the interval where x is greater. Let's look at one more example of finding the intervals of increasing or decreasing. So let's pick out A, B, and C, and then let's find the x value of the vertex. So we'll have, and I picked out B as -16, but it's actually +16 there, so I correct my mistake. So our x value is -2, and we plug in -2, and we're going to get -3. So the vertex is at the point -2, and not -3, -19. Our graph opens upward, so this will be a minimum. Our domain is all real numbers, and our range are the y values that are greater than or equal to -19. So let's do a brief sketch. So our vertex at -2, -19, dash that axis of symmetry. Notice on the left side, we have an interval that is decreasing, all the x's that are less than -2, and on the right side of that axis of symmetry, where the x's are greater than -2, that's an interval of decreasing. All right, this concludes the Part 1 notes of quadratic functions, Concept 7. We'll pick this up in a Part 2 video.